Hey everyone, and welcome to your final video lecture for the semester. Today we are going to be talking about system administration and building software. Let's start by customizing your terminal. You can customize your prompt by editing the .bash profile file, and we've got right here something called the PS1 variable, which controls the look of your command prompt. And what's shown here in the quotes is just a common configuration for that. We've got the /u, which stands for your username. We've got the /h, which stands for the host server name. And then we've got /w, which displays your current working directory. After you save your .bash profile, you don't need to restart the terminal. You can actually just run source.bash profile here, and that will apply the changes immediately. Let's look at some tools for inspecting files. We've got the file command, and this tells you the type of contents inside a file. So for example, you can run files/etc/passwd or file/bin/ls to see what they are. We've got the wc command, and this stands for word count, and it gives you the number of lines, words, and bytes in a file. You can try this on your history file by running wc.bash history. To check to see if files are different, you can use the cmp command, which performs a binary comparison and reports if files differ, and if so, where the first difference occurs. Then we have diff, which shows exactly what lines differ and how to change one file to match another. And we have an example here, which just creates two similar directory listings with slight time differences. So this first one here redirects a detailed directory listing to a file, and the second one is literally the exact same, except it will show different timestamps. So using CMP, it will show nothing if the files are identical, or it'll report the first byte/line that differs between the files. And then this diff output here uses a special notation, which I'll explain in the next slide. And you can also clean things up with this command here, which will remove both of the test files using that wildcard right there. Okay, so the diff output uses specific symbols. So for more details, you can go to these sites, but basically it'll use the letter A for added, D for deleted, and C for changed. And interestingly enough, this diff command is the foundation for version control systems like Git that you've learned about. We also have shell variables, which are similar to system variables in Windows. An important one is the path variable, which tells the shell which directories to look in for commands. You can use the set command to display all of your current shell variables, or pipe it into head, as shown here, to see just the first 10. Now we've got something called an alias. So to save keystrokes on commands you use frequently, you'll want to use an alias. For instance, if you often type ls-al with the pipe operator and more, you can create an alias by typing this underlined part here. And now you've made an alias where you can just type dir and run that same command. If you add this to your bash rc or bash profile file, it will be available every time that you log in. Something that's really cool is that your shell remembers what you do, and commands are saved in memory so that you can execute them again, and you can scroll through them with the up arrow. But to see a list of your previous commands, you can just use the history command, and then Again, here, piping it to tail helps limit the output. So in this case, if you want 5, you can define that you want to see the last 5 commands that you've used. And what's really cool is that each command is assigned a number. And so, for example, if you see a command that is number 12 that you want to run again, you can simply type the exclamation point 12. Now, regarding administrative privileges or root access, there are 3 ways to get this. Firstly, you can log in as the root user. Secondly, you can use the su command to become the root. And finally, you can use sudo to execute specific commands as the root. Now, the first 2 are relatively dangerous and often not available to developers, so usually you'll be relying on using sudo, which requires privileges set up by the root user. So if you'd like, you can try this out. The ID command shows your current user ID, the group ID, and all of the groups that you belong in. And so the sudo ID runs the ID command as the root, which will show elevated privileges. In general, we've got 2 different approaches to searching for files in Unix and Linux systems. Firstly, we've got locate, which searches a pre-built database, which is usually updated nightly via a command such as updatedb. And it's very fast, but it also might not show recent files. So then we've also got find, which searches the actual file system in real time, which is slower, but you know that you're always looking at current files and it's more flexible in general. You can also type in locate past WD, which will quickly find all files with the past WD in their path from the database. You can also look at the head, which is going to show the first 10 results. In this example here, using find/etc-name past WD, this searches the etc directory specifically for a file named past WD. Then we've also got this redirection code snippet, which will redirect error messages to nowhere. And basically, that just cleans up the output. And there are a lot of options that you can use with the find command. So if you'd like to look at those, you can use man find, which again will show you the manual for the find command. When it comes to installing software, the tools depend on your distribution. So if you're using Debian, Ubuntu, or Mint, you can use this command here. Mac OS, you'll use brew. And then if you're using Red Hat or CentOS or Fedora, then you can use these. You can update package lists before you install the new software, which makes sure that you get the latest versions. Again, here we've just got a couple of examples of installing software commands. Here is the syntax for removing software. It's just as simple as installing software. Okay, moving on to HTML3. Now we are transitioning from system administration commands to a practical application. So for this assignment, you'll want to connect remotely to our server. You can also use VS Code to do this. It might be easier to look at files that way as opposed to simply using the VI editor. Here's a summary of the instructions for the HTML3 assignment, but please look on Canvas for more information on that. Now, if you would like to SSH via VS Code, you can click on this button here, which should bring you to the extensions store, type remote, and install the extensions shown on the screen. Also, TypeScript extensions may cause performance issues or conflicts on remote connections. So if you search for this right here and disable these 2 extensions, that can prevent the language server from consuming resources on the remote server. Again, make sure that you're disabling, not uninstalling these. But If you're not experiencing any issues, you don't need to do this. Just if you're wondering why there might be slowness or connection issues, this might be a setting that you can change. So this button here, it might be blue, it might be green, or honestly, depending on if you have other themes installed, it could be whatever color, but the green icon in the lower left corner indicates the remote connection status and control. So if you click it, it'll open the remote command palette with connection operations. You'll want to click connect to host, which will initiate an SSH connection configuration. And you can also save these configurations for quick access in the future. And again, you don't need to do it this way, but it can just be convenient if you don't want to have to keep SSHing and putting in your password and everything like that directly in the terminal. So you can read here the instructions on exactly how to set up the VS Code remote OS features. And there's also one more way to SSH, and you can do this without a password. I'm not going to get into this, but this slide simply displays how to do that. Finally, we are on our last section, which is building software. So sometimes software isn't available in Package Manager, and you'll have to build it from source. So the standard workflow is that first you use wget to download the source code. Usually that's formatted as a compressed archive. Then you use the gunzip command to uncompress the file. Always make sure also that you're reading any documentation such as README. Then you're going to want to create a makefile by running a configuration script, and this sets up build instructions for your specific system. Fourth, you'll want to compile the code using the make program, and this turns source code into executable programs. And then finally, you will install the compiled code in the correct directory using make install. For example, if we want to install the Hello World program, we can create a directory where we install the program using the mkdir command that we know. Then we'll run the configuration script with /configure. Now that we have our makefile, we can build the software. You'll simply type make. This reads the makefile and compiles the source code into executable programs. Then after make finishes, type make check, and this will automatically run tests to verify that everything is built correctly. And then finally, type make install, and this copies the compiled programs to the installation directory. If you're installing something to a system directory such as /usr/local, you might need to use the sudo command. So it would be sudo make install so that you have more permissions. So just keep that in mind if you run into any issues. So again, here is the complete workflow in order. I would make note of this. This is just a summary slide of everything that we reviewed. And that wraps up today's video. Great job, everybody. That was your last video lecture again, and have a great day.